the elevation of a hill at place P, which is due east of it, is 48 degrees, and at place Q, which is due south of P, the elevation is 30 degrees. If the distance from P to Q is 500 meters, find the height of the hill. So I've kind of drawn up just a basic idea of what this is showing. So we've got this hill here, and there's P, which is east of the hill. I guess I'll make that point H. That's the top of the hill. And its angle of elevation is 48 degrees. So that means we've got a right angle triangle here, and that angle will be 48 degrees. And then due south of P, which has a distance of 500 meters, that angle of elevation is 30 degrees. So that's why it's a right angle as well. It's hard to see here, but I've got a right angle for the Q part of the triangle, and I've got a right angle here for the P part of the triangle. And then we've got another triangle here, which is just on the ground, which is a right angle because P, this is an easterly line, and this is a southerly line. So that means that it's meeting at a right angle here. I'm going to quickly draw up these three triangles again, but just on a 2D plane, just so you can see the different types of triangles we have. I'm going to call this point O, as in like for the origin, just because I just would like to have a label for every corner at the very least. So the first triangle we have this is going to be our P, our O, and our H. So that's a right angle, and this is 48 degrees. Okay, we can find that angle. I'm not going to because we don't necessarily need it. And until we do need it, we'll just have to see. This length is H, and this length is Q. Okay, we'll do another triangle. So we've got another one. And for this one, we're going to have point H, point Q, and the O. This is also a right angle triangle with an angle of 30 degrees there. And this is length P, and this is length H. Okay, and then the last triangle we have is the one that's on the base. Which is a right angle there. This is Q, this is P, and this is 500 meters. And that's point Q, that's point P, and O. So the reason why I've labeled all these sides in the particular way, if that's point P, we know that the side opposite that corner or vertex is lowercase p, and that's the same for Q as well. Now we want to find what H is, okay, the height of the hill. Find the height of the hill. Okay, so in order to do that, we need to know what Q is going to be, what P is going to be. So just to kind of demonstrate how we can get H as a possible option, we know that Q is very important, that P is very important, but if we work with this triangle, we don't really get any number values because we've got too many unknowns, and that's the same for this triangle here. So what we have to do is solve all these triangles simultaneously, and that's what makes this question a bit difficult. We know that we can get our P and Q value if we use Pythagoras for this triangle. So we know that P squared is going to equal Q squared plus 500 squared. Okay. Now, the issue with this is we don't know what P is and what Q is, but we can kind of get an idea of what it would be using these triangles. So for this triangle here, I'm going to label these triangles. This is going to be 3. That's 1 and that's 2. Just so you know which one I'm working with at a particular time. For triangle 1, I'll just do some working for 1 over here. We know that the tan of 48 degrees is equal to the opposite over the adjacent. So that can be H over Q. Alright, but we want to know what Q is. So I'm going to switch these. So Q will equal H over tan of 48. Okay, so that's our Q value. I'm going to leave it like that because, of course, we can't evaluate it because we don't know what H is. For the second triangle, we can do the same thing. So we're going to get the tan of 30. That's going to be H over P. So P is going to be equal to H over tan 30. Okay, so now we have our Q and our P. We can pop them in. And the reason why we're doing it this way is because that leaves H as the only unknown instead of P and Q. Okay, so if we substitute these values in, we're going to have H over tan 30 squared. That's going to be equal to H over tan 48 squared plus 500 squared. Okay, so let's simplify this just a little bit, just to make things a bit neater. I'm going to get the h's all together and the whole number on the other side. So if we have 500 squared, and to get 500 squared on its own, we need to subtract this. So we're going to have a positive H over tan 30 squared, and we're going to be taking that away. H over tan of 48 squared. Okay, so in order for this to work, I'm going to have to evaluate some things. So 500 squared, it's going to be 25 with 4 zeros. Just a little bit of motorbike noise for you. And we'll just simplify this. So we're going to have H squared over tan 30. That's all squared there. Minus H squared over tan 48 squared. And because we're subtracting fractions, we need to make sure that they have a common denominator. So that's going to be there H squared multiplied by tan of 48 squared minus H squared multiplied by tan of 30 squared. So multiply that by that, all over those two multiplied together. So we're going to have tan 30 squared, tan 48 squared. Okay, so far so good. We want to get H by itself, and we can see that there's a common H squared on the top there. So we'll have 250,000 equal to H squared on the outside of, we'll do this whole fraction here, what's left. So we're going to have tan of 48 squared minus tan of 30 squared all over tan of 30 squared times tan of 48 squared. And then we need to just get H squared on its own. So when we do that, we need to divide both sides by this hideous thing, to be honest. Now when we're dividing by a fraction, that means we're going to multiply the reciprocal to both sides. That makes things a bit easier for us instead of just dividing. So the way this is going to work, I'm going to run out of space. I'm just going to shift this up so I've got a bit more room here. We're going to have H squared is equal to, now it's going to be, as I said, 250,000 multiplied by the reciprocal of this, which is the same as dividing by this. So I'm going to multiply it by tan 30 squared, tan 48 squared. So at the moment this is just what's on the bottom here, all over what's on the top. So we've got tan 48 squared minus tan 30 squared. And if we evaluate that, we'll get the equivalent of H squared. So if we square root both sides, we'll be able to get just H. And we'll take the positive value for H because it's a length, so we know it's going to have to be a positive value. And then we just have to type all of that into our calculator and we'll get a solution. Okay, just make sure there's no glare there. So the square root of 2, 5 with 4 zeros times tan of 30 squared times tan of 48 squared over tan of 48 squared minus tan of 30 squared. Okay, and of course made an error there. Let's just double check what that might have been. Oh, I've got a bracket there. I just need to pop it on at the end of my fraction. There we go, and we're left with our answer of 337, and it didn't specify like how many decimal places, so we'll just do it to 2.92, and that should be meters. Okay, so certainly a complicated question, and what results in lots of working and lots of writing, just because we're stuck writing things like tan 30 and things like that. But that's just to keep everything exact. Don't estimate until you get to the end. Don't round until you get to this final value. If you do, you'll get something a bit different, and you may not get full marks just because it might be too far from the actual answer. You'll still get a lot of marks from the working, however. So the key ideas to take from this example is that essentially, if you're given a situation where there may not be all the information that you think you may need, the goal is to get just one unknown. Once you have one unknown, you pretty much can go the rest of the way. Obviously, that way might be a long way, but you'll get there.